Hello and welcome. Have you ever wondered if you could create electricity directly from heat, without any moving parts like turbines or engines? Today, we're going to explore exactly that by looking at how a thermoelectric generator, or TEG, works. These fascinating devices can turn a simple temperature difference into usable electrical power, and the science behind them is surprisingly straightforward. It all begins with a core principle discovered in the 1800s called the Seebeck effect. This effect states that if you take a conductive material and make one side hot and the other side cold, a voltage will appear across it. This happens because the heat gives energy to the charge carriers, like electrons, causing them to move from the hot end to the cold end. This flow of charge is essentially electricity. However, a single material doesn't produce much voltage, so to build a useful generator, we need a more clever design using special materials. This is where semiconductors come in. TEGs use two types, N-type and P-type. N-type semiconductors have an excess of electrons, negative charges, while P-type semiconductors have a deficit of electrons, which we call holes, positive charges. In a TEG module, tiny pillars of N-type and P-type material are arranged side by side and connected with small metal plates, forming a series circuit. This entire array is then sandwiched between two ceramic plates. Here is how it all comes together to generate power. First, one ceramic plate is heated, while the other is kept cool, often with a heat sink. This temperature difference, or delta T, is the most crucial part. The bigger the difference, the more power you get. Second, this heat forces the electrons in the N-type pillars and the holes in the P-type pillars to all move towards the cold side. Third, because of the clever way they are wired in a zigzag pattern, this movement creates a single, unified flow of current that can be used to power a device. You can find this technology in amazing places, from deep space probes like Voyager, which are powered by the heat of radioactive decay, to camping stoves that use the campfire's heat to charge your phone. While not as efficient as traditional generators, their silence, reliability, and lack of moving parts make them perfect for specific applications. Thank you so much for watching. If you found this explanation helpful and want to learn more about how technology works, please consider liking, sharing, and subscribing to support the channel. It helps us continue making more videos like this one. See you in the next one.